Okay, first things first. This is a type of problem you guys have seen before, okay? Evaluate 2x minus 3 if x equals 3. What is this telling me to do?
2 times x minus 3.
2 times x minus 3. So if x is equal to 3, what am I doing?
If it equals to 3.
Say again?
2 times 3 minus 1.
Okay, so we need to take the 3, since it's equal to x, and I am allowed to replace x with 3, correct? I think that's what you're telling me. So we can take the 3, plug it in for x, and so then we would have 2 times 3 minus 3. What is 2 times 3?
6.
And 6 minus 3? Right? Simple. Evaluate 2x minus 3 if x equals 3. They're telling you what the variable is equal to. They're telling us what we can substitute for the variable. We plug that in, we evaluate it, get an answer, right? Everybody good with that? We've done those before. You've done those before. Now, that's the same problem. This problem right here that I just uncovered, that problem is telling you to do the exact same thing. It just looks a lot different. They're using what they call function notation. And oftentimes it is this notation. It's what this looks like tends to what scares people off. They're kind of like, oh my gosh, that looks really algebra-like. That looks very mathy. That looks difficult, okay? That is the same problem. That is telling you to please take a 3 and plug it in for x and tell me what you get coming out of it, okay? So, with that said, what is function notation? Okay? Well, function notation is those letters in parentheses you see there on the side. Okay? Now, these letters, F, G, and H. All those are, that's the name of the function. They're giving it a name. That's the F function. That's the G function. That is the H function. Why are they giving them names? Because if we have a bunch of functions, how do I know which one's which? Okay? It's kind of like, why don't we give our kids names? Well, we need to be able to tell them apart, right? That's all they're doing with those letters, guys. That's the F function, that's the G function, that's the H function. Okay? The letters inside the parentheses, okay, what are those? Those letters tell you what these functions depend on. It's a dependency statement. The F function depends on x. It depends on what you put in there for x as to what you're going to get out. That's all that variable is. It tells you what the function is depending on. You will probably notice, I think, that the variable in the parentheses matches the variable in the function because that's what it depends on. F of x, G of x, H of z. This H function depends on what we put in there for z. Guys, that's all that stuff means. F of x, G of x, H of z, it's a dependency statement. They're naming the function and they're telling you what it depends on is all that is. Okay? Now, true story. When I was a senior in high school, I'm sitting in pre-calculus class, and this type of stuff is coming up, and nobody told me what I just told you. So all the while, as I'm sitting through all these math classes and I'm seeing this, it's very uncomfortable. I'm thinking, I really don't know what that means. I don't like that. So literally, here's what I would do. I would take my pencil and I would scribble out, say, the F of x, and I'd put a y there. And then I was okay. And I was like, that's what that is. That's really all that is, guys. It's output. It's output. Y equals 3x minus 4. That looks familiar to us. You guys have seen that. That's slope-intercept form. We put something in for x, something comes out for y. X is input, y is output. Okay? But instead of a y, in order to discern between these functions, they give them names, hence function notation. That's all that is, though. But I would literally do that. I'd scribble it out and put a y. And then, of course, later on, I got to college. Somebody finally explained it to me, and I went, oh, my gosh, that was easy. I didn't get it. So that's why I'm trying to relay that to you now, okay? This stuff isn't really as scary as it looks. You just have to know what it's telling you. It's the name of a function. It tells you what you depend on, okay? This stuff right here, guys, this is the main stuff. That's what we're worried about. That's what we're going to operate on. That's where we're going to put the numbers, okay? Any questions about that? Everybody okay with that? That's really all it is, all right? So we get to this, all right? Now, the functions there on the left, those are the same functions I had on the previous screen, okay? So these are the given functions. This is what your assignment's going to look like today, all right? I'm going to give you some functions. I'm going to give them a name, such as you're seeing here, f, g, and h. And then right here, I'm going to tell you what to go evaluate, okay? So if we take a look at this first one, that's f of negative 4. That's kind of how you read that, f of negative 4. What is that telling me? That is telling me to go to the f function. Which one of those functions is the f function? The first one. I go to the function labeled f, hence the name. Everywhere we see an x, because it depends on x, everywhere we see an x, I'm going to put a negative 4 in there. I'm going to take this negative 4. I'm going to go put it in there for x. 3 times negative 4 minus 4. What's 3 times negative 4? And what's negative 12 minus 4?
Negative 8. Oh, shit. I mean, negative 16.
Might need to, and it's probably been recorded, so thank you.
Oh, my God.
There you go. Censor. Beep. Thank you, Mathla. Negative 16. I don't know. Maybe a parent will get a kick out of that if they sit and watch the video with their kid. I don't know. Negative 16. Guys, that's it. So f of negative 4 equals negative 16. That's it. That's all that's telling you to do. Guys, we're not taking negative 4. We're not plugging it in over here for this x. We don't have to plug anything in there. All that is a name and tells you what it depends on. Take the negative 4, plug it in, evaluate. Look at the next one. H of negative 2. H of negative 2. What function are we going to? We're going to the h function. Which function's the h function?
H, the second one. Oh, the third.
The third one. Okay? So this tells us where to go. Guys, this is why these functions need a name. If they were all setting here y equals, y equals, y equals, I'd have a hard time knowing where to go with this stuff. But this tells me exactly where to go. Now, everywhere I see a z, I'm going to put a what?
2.
Put a 2. So that 2 is going right there. Negative 4 times 2 plus 5. What's negative 4 times 2? And what's negative 8 plus 5?
Negative 3.
It's that easy. How about the next one? Which function are we going to?
The second one.
Going to the g function, which is the second one. Now, look at your g function. How many x's are in the g function? 2. So anywhere we see an x, we're putting a what?
Negative 1.
Negative 1. Now, make sure that we get that into all the right places. I always use parentheses when we replace a variable. That's negative 1 squared plus 2 times negative 1 minus 1. Be careful. Be careful when you're plugging negative values into things that are being raised to powers. What is negative 1 squared? 1. What's 2 times negative 1? Minus 1. What's 1 minus 2 minus 1?
1 minus 2 minus 1, so it would be negative.
Be what?
It's going to be plus 1.
No, yeah.
Is what? 1 minus 2 is what? Negative 1. And what's negative 1 minus 1? Boom, there you go, good. Negative 2. Okay? You guys, we okay with those first three? Now, take a look at this last one. What are they asking you to plug into this last one? 3y, okay? Now, most of the time, they will ask you to plug a number in. But it's not unusual if you need to evaluate a function with another function, okay, or an expression. Please go to the function labeled f, which is which function is f? The first one. And everywhere you see an x, put in a 3y. Guys, that's okay. Do what they're telling you to do. Go to the f function. Wherever you see an x, put in a 3y. I replace x with 3y. That's what I did right there. What is 3 times 3y?
9y.
That is 9y, and then minus 4.
No, 5y.
Are you allowed to combine those two terms? No. 9y minus 4, those are unlike terms. Guys, that's as far as I can go with it. 9y minus 4, done. Okay? If you plug in an algebraic expression, you're probably going to get an expression back out more or less. There's a good chance you're probably not going to combine everything. So just kind of watch for that. You're going to get to practice that today. I'm going to give you a few of those to do, but most of the time it is just a number. But that's all this is. If you can get past what it looks like and just get down to going, okay, that's all this is telling me to do, it's a piece of cake. Questions?
Yes, sir.
Questions? Okie dokie.
Where's the paper at?
There we go.